Hey everyone, welcome to JS Cafe, and in today's video we are going to talk about responsive images. So without wasting any time, let's get started. So if you are new to this channel and seeing this video for the first time, then let me tell you this video is part of the system design series that we are having on JS Cafe YouTube channel. And in this particular playlist is about asset optimization. And previous to that, we had created a playlist related to network optimizations. Where we have discussed approaches and techniques where we can optimize networks of our website. So if you haven't checked that out, I'll recommend watching that particular playlist first and then landing on to this asset optimization. So yeah, so that was a brief about the system design playlist. Now let's deep dive into this particular topic, that is responsive images. So before the starting the topic, I had written a one line, that is, it is unfair to load high density images on low end devices. So what I mean by that is, let's suppose you have a website, you have to cater images on your website. Okay, now your user can have a very good high performing device, and there are certain users that have very low end devices, or we can call them low performing devices. Like for example, the system on which I am sharing my screen is a low end device. Anyways, so my point is that if the device is low end, then it's better to render low quality images, and if the device is of high end high quality device, then it is better to render high quality images. Okay, so what would happen, let's suppose you have smartphones, right? So smartphones, they ideally network over 4G network, right? They or over 5G or 3G. So it's not a good idea to render high quality images that are of approximately 1 MB 2 MB on someone's smartphone, right? Because that would again add a network load on the device, and this might disrupt the user experience. So as a developer, it is our responsibility to render low quality images and high quality images according to the user's device type. Okay, so let us understand the problem first. Having outstanding images on Retina laptop, the vast majority of our users are on iOS, macOS. This is where DPR comes into the picture. Avoid loading heavy images on smartphones. That would slow down the pages. 70% of our users are on mobile devices. So I'll tell you what these 2 points are telling, right? So there were certain laptops before Mac OS where there was no concept of DPR. Okay, so DPR stands for density pixel ratio. Okay, so when we write 1 pixel in CSS, is it equivalent to 1 pixel on your screen? Sometimes yes, sometimes not. Okay, let us discuss the scenario when it is happening. Okay, so on high density devices, or we can call them as retina devices, there is a concept of DPR, density pixel ratio. So if your device is of 2 DPR, okay, and if you write 1 pixel in CSS, then that would be equivalent to 4 by 4 matrix into that particular device. Okay, so I'll explain this once again. Okay, so if you are on a regular device, okay, that has a 1 DPR, so 1 CSS pixels is equals to 1 device pixel. Okay, so if you say 1 pixel in CSS, that would be equivalent to 1 pixel on your screen, okay, on the device on which you are rendering your website. That is perfectly fine. But when you switch to retina devices, okay, for example MacBooks, okay, and let's suppose your MacBook is of 2 dpr. Now when you write 1 pixel in the css, that would not be equal to 1 pixel on your screen, but rather it would be equal to 4 device pixels. Okay, so when you write 1 pixel in css, that would be equal to 4 device pixels. Okay, and this is the reason why images appear pixelated on high density screens, right? Let's suppose you have 500 by 500 cross image. Okay, now when you render it on 1 dpr, that is perfectly fine, but now when you render it on 2 dpr, the same image is going to appear pixelated. Now if you move ahead and render that particular image on 3 dpr, that is equivalent to 9 device pixels, then again the image would be pixelated much more than the previous one. Okay, this is the problem with these retina devices or the dpr kind of devices. The higher the dpr of the device, greater is the chance that your image would be pixelated. Okay, and again, this point we have discussed already. Avoid loading heavy images on a smartphone, because smartphones generally use mobile networks and they are kind of slow sometimes, so it's better to render low quality images, and that is perfectly fine. Okay, so how do we exactly solve this density pixel ratio problem? Okay, this is a huge problem, right? And before jumping into the solution, I would like to tell you that devices can be of various DPR values 1, 2 and 3 and so on. And if you want to check the DPR of your device, you can do window.device pixel ratio, and this would print out the DPR value of your device. Okay, now let us consider one example. Okay, let us see what this is telling us. So if you want to display a photo that is 300 by 200 css pixels, you'll actually need an image of 300 by 200 for desktop with dpr1. Makes sense. Okay, because 1 css pixel equals to 1 device pixel. Okay, so if my image is of 300 cross 200, then it is perfectly fine. Okay, now if my dpr is 2 and I want to render 300 cross 200 image, okay, now this rendering this particular image will pixelate it. Okay, so what I need to do is I need to convert that image into 600 by 400 for MacBook with dpr2. Okay, so when the dpr is 2, just multiply the dimensions of the image by the dpr value, and this would give you the dimensions of the image that is required. Okay, and let's suppose if the dpr is 3, then you'll require 900 cross 600. If the dpr is 2.5, then you'll require 750 cross 500. Makes sense. So it means that we will have to keep a set of images of various dimensions, so that we can render that image according to the need. Okay, because what I see that is that I need to maintain an image of 300 by cross 200, then again 600 by 400, then 900 by 600, and 750 by 500. So I'll have to maintain a set of images of these dimensions, right? And depending upon the scenario, I'll render that particular image according to the need. Okay, so how do we exactly solve this issue, and how exactly can we render images of specific dimensions according to the DPR? So here comes the srcset attribute of the image tag into the picture, and we will see how this is going to help us. So this is a image srcset attribute. Okay, so let's go to the code and see what is happening. Let me copy this once. Let's go to the code base and let me replace this once. Okay, now I have 3 images. Okay, I have an image of 500 cross 500, which looks like this, and 1x is written over here. I have another image of 1000 by 1000 written 2x. I have another image of 1500 cross 1500 written 3x. Okay, I have 3 images. Now, so if I somehow just remove this srcset, okay, and I just use img src equals to cat 500.jpg. okay, I am using 500 by 500 image, and if we go to the console, right, and let's see how the image looks. Okay, I increase the size and I increase the size. You can see that the image is started getting pixelated, right? This is getting pixelated very much. Now if you want to change the DPR value, okay, and if you are using Google Chrome, you can right click, you can go to the developer console. Okay, open this device toolbar, and on the top right you have a nudge saying that add or remove device pixel ratio. Okay, I guess for you it might be removed. Okay, once you click this, you can see this DPR drop down over here like this. Now I can change the DPR value on the fly. Okay, and I refresh it. Okay, so currently the DPR value is 3, and this is what it looks like, and you can see the image is highly pixelated. Okay, and I'm rendering the 500 by 500 image. Now is there some way where if I change the DPR value to 1, I should be able to see 1x image? If I change the DPR to 2, I should see 2x. If I change DPR to 3, I should see 3x. Okay, now I'll uncomment the code which I just removed, and I'll add it over here. Let me add the indentations. Okay, now see. So I have a src set, okay, in which I have to mention that if the DPR value is 1, render cat 500. If the DPR value is 2, which is indicated by 2x, render cat 1000. If the DPR value is 3x, which means that the DPR value is 3, render cat 1500. Okay, now we will see this particular code in action also. Now if I change my DPR value to 1, and make sure that you have disabled the cache. Okay, sometimes what browser does is that it caches your images into the memory, and even though you are doing the development and trying to change the images according to the DPR values and stuffs, you won't be getting because the image is already cached. Okay, so make sure that you have disabled the cache, and let's change the DPR value to 1 and refresh it. Okay, I see that 1x image was loading, and also you can see in the network call only the image 500 was loaded. Okay, now if I change the value to 2 and refresh, see that only cat 1000 was loaded, not other images were loaded. Okay, and I can see the 2x over here. If I change my DPR value to 3 and reload, you can see that the 3x image was loaded. Okay, so depending upon the DPR value, we can render images accordingly. Okay, but we can do one step better than this. Okay, what I mean by that is, this was a scenario that changing the image according to the DPR. Okay, we change the image according to the DPR, 1 DPR, 2 DPR, 3 DPR. Okay, now there is another scenario where we can change the image according to the actual image width in the viewport. Okay, let me explain this line once again. So whatever width the image is taking on the viewport, according to that I can actually render images. Okay, I'll copy this particular code and I'll tell you what it is. Okay, and for example, I am taking the width as 100%. Okay, so the images are set to by default 100%. Okay, so that they take the whole width of the container, and we can we can see the changes clearly. So what I'm having right now is src set cat 500 jpeg on 500 w. So w stands for width. Okay, so the moment our image takes 500 device pixels, render this image. Okay, the moment Okay, so device pixel, I hope it is clear to you what I mean by that. This is not equal to CSS pixels. Okay, we have discussed already over here that what a device pixel is and what a CSS pixel is. Okay, so this W means that device pixels. So if the image is taking 500 device pixels, then render cat 500. If it is taking 1000 device pixels, then render cat 1000. If it is taking 1500 device pixels, okay, then render cat 1500. Okay, I'll tell you over here. Let me change the DPR to 1, and I'll tell you how this particular code will behave in different DPR values. But for now, let us have a look at this example with DPR value of 1. Okay, the DPR value is set to 1, and you can see that the current width is 584, which is greater than 500. Okay, so if the image is greater than 500, then we will render cat 1000. Okay, if we are less than 500, if we are exactly 500, for example, we are exactly 500. Okay, and I refresh it, you can see that we are rendering 1x image. Okay, this is perfectly fine. If we go 1 pixel above 500, okay, and I refresh it, you can see that we are rendering 2x. Now if our width goes till 1000, then we will still render 2x. If we go even 1 pixel above 1000, you can see that we are rendering 3x. Okay, and whatever value we increase above 1000, we will be loading 3x values. Okay, cat 1500. So this is how powerful src set is, right? Now let's suppose your device, how much generally a device width is. So generally a device width is around somewhere 320 pixels. Now if I refresh it, I actually loaded a low resolution device on this particular viewport. Okay, this actually helped me save bandwidth for the user and render image according to the size of the user. Okay, cool. So I think this particular part is clear to you. If not, do let me know in the comments. But now let us see something tricky. Okay, now if I change the DPR value to 2, okay, and I refresh it, you can still see that 1x image is loading. Okay, now let me change the value to 375 pixels. Oh, what? 2x? How what is happening, right? I had set it to 500 device pixels, right? But currently the device width is 375 pixels, which is less than 500, right? So ideally it should render cat 500.jpg, but what I am actually seeing is that it is cat 100.jpg, right? Let me reload it again. Oh, it is still giving cat 1000. So what is happening, right? So behind the scenes, src set, or we can say that this browser is doing some calculations. Okay, I'll tell you what. So the DPR value is 2. Okay, keep that in mind. And our range of images is 500. Okay, by range I mean is that the width of this particular image is 500, the width of this particular image is 1000, the width of this particular image is 1500. Okay, so we have 3 widths in the scenario. Okay, now let's come back to here and see the calculator. Now I am at width 375. Okay, let's change it to this 320 first. Okay, now browser sees that there are 3 particular images. Fine, the one he can render is 500 pixel image. Okay, so what it does is it divides the width of the image with the width of the viewport, okay, which is 320 pixel, and you get the value as 1.56. okay, keep that number in mind. Now I also have an image with a width of 1000 pixels. Now again, if I divide 1000 by the viewport, okay, which is 320 pixels, I get 3.125. Now tell me, if browser wants to render 500 and 1000, which one it will render? Okay, so what it does is it checks the value, okay, which we got after dividing the image width and the viewport width. Whichever value is closer to the DPR value, it renders it. Okay, so we see that 1.56 is much closer to 2 than 3.125. okay, so it will render 1x image. Okay, if you refresh it again, you see that it is rendering 1x image for 320. Okay, because the value was close to 2. Now if I change my DPR value to 2, okay, it is already 2. Now let me change my viewport to width of 375 pixels. Okay, now if I divide 500 with 375, I get value of 1.33, and if I divide 1000 with 375, I get value of 2.66. okay, now ideally you can see that 2.6 is much or I should put it this way, 1.33 is way too low than 2 to render on the screen, because 1.33 is actually very low for browser to render it, so it goes with the value of 2.6. okay, so this is why it rendered 2x image, that is of 1000 by 1000. okay, so this was the reason why it was we are seeing 2x image even in 375 pixels. okay, so this is the calculation behind the scenes, right? So we see that this srcset attribute is actually really powerful, and it can help us save a lot of bandwidth and also help us optimize the assets that are going to be rendered on the user's device. okay, so yeah, and also there is one more thing, that is we can also add media queries in this srcset attributes. So again, that would add much more complexity for this video, and I want to keep the examples very cut and clear and really straight to the point. So you, if you want, you can really check the MDN website on how we can write media queries in the srcset. But again, that case actually gets messy sometimes. okay, and it is not required in many of the cases. Most of the time your requirement will be fulfilled while using 500w 1000w, meaning that this width a property, right? Or you can use the DPR values also. okay, so yeah, this was all in this video. If you have any doubts, any questions related to srcset, or you found something missing in this part, do let me know in the comments. I'll be happy to answer your questions. And also from this video onwards, we'll be setting like targets for each video. So for now I am aiming for 50 likes on this video. ठीक है, अगर लाइक नहीं किया है तो जाके लाइक कर देना वीडियो. ठीक है, इफ़ यू सी इफ इट इज़ नॉट 50 और अबव, ठीक है, तो जाके वीडियो लाइक करो. एंड टिल नाउ इफ यू आर फाइंडिंग माई कॉन्टेंट यूजफुल, if you are finding that the content which I am preparing is really helping you in understanding core front-end concepts and also helping you do better in your front-end interviews, then please share this channel with your friends and peers. And also do give it a shout out if you want to over LinkedIn or Instagram or anywhere you want. That would again will be a great morale boost for me as well. So yeah, this was all in this video. Till then, take care, goodbye, see you in the next one.